they know. Just give it a shot.
Also, the camera is in the middle of the room now. Someone said that they were concerned because they could hear my answers to questions, but couldn't hear the actual questions. So now it's closer to you, so when you ask questions, the camera will pick it up, which should be good. But realize that if you're chatting about whatever, then the camera will pick it up. Like, did you hear what happened in so-and-so's class? Oh no! I hope that's a secret. No, not anymore. Anyway, so next unit, molar mass. Molar mass. Okay, so molar mass is interesting. What I'd like you to do is take a look at the periodic table, either there or your yellow one. And what do you notice about the atomic numbers?
Numerical.
They are numerical. The numbers are numerical. What about the specific numbers themselves? What do you notice about them that is interesting? If you were to classify the numbers, how would you classify them?
Real.
They are real numbers? Yep.
Big.
On the right track. So I look at carbon, I see a 6. I look at nitrogen, I see a 7. I look at oxygen, I see an 8. They're in order. Yep. They're what?
Single-digit numbers.
Yeah. They're a single-digit number with the case with selenium, but when you look at selenium, bromine, and krypton, 34, 35, 36, what do you notice about those numbers?
They're in ascending order.
They are in ascending order, and they are integers. They're whole numbers, okay? The atomic number is the number of protons. They are whole numbers. But when you look at the mass, you notice something very different. If you look at gallium, gallium has a mass of 69.723. Germanium has a mass of 72.6. Arsenic, 74.922. Why isn't the mass a whole number?
Because it's also taking into account neutrons.
Mm-hmm. Yep. But so if we say protons have a mass of 1 and neutrons have a mass of 1, we should have big numbers, and they should be whole numbers. How come the masses on the periodic table are not whole numbers?
Isn't it an average of like all the samples we've had?
Exactly right. Is that what you're going to say?
Electrons have some.
They do have an itty bitty amount of mass, but not enough to make a difference. But yeah, exactly right. Cody's exactly right. It is an average of all of the isotopes of an element. So it's not a simple average, though. It's a special kind of average called a weighted average. We'll talk about in a second. But it's an average. So what scientists do is they look at all the isotopes of a specific element and how much there is, and they make an average. Now, we can do an average of U if we basically said, all right, I'm going to average the average birthday of everybody in the room. We're going to assign 1 to January 1st and 365 to December 31st. If we averaged all of your birthdays, we'd end up about June 10th. Does that mean everybody has a mass of June, or everybody has a birthday of June 10th? No. Does it necessarily mean anyone has a birthday of June 10th? No. It's an average. But it's not a simple average where you add everything up and divide by the number you have. It's called a weighted average, where we use percentages. When do you use a weighted average that has percentages? Your GPA. So you use your GPA, and when you want to know what your grade's going to be in December, you do this math. You say, all right, I'm going to take my Q1, and I'm going to multiply that by 40%. I'm going to take my Q2, and I'm going to multiply that by 40%. I'm going to take my semester exam, I'm going to multiply that by 20%. Then I'm going to add up all those pieces, and what I get at the end will be my final grade that goes in my transcript in December. You've done this before, right? You've all been in high school for a while, so we're like, nah, I don't even bother. But anyway, if you want to know what your grade is going to be, that's what we do. That's what the computer does. So let's go ahead and give it a shot. So we can warm our brains up and get our calculators, make sure our calculators work. What did you get for Q1? Throw out a number.
80.
80. We got an 80 for Q1. What did you get for Q2?
69.
How much? 92? 92? And what did you get for the semester exam?
69.
69, okay. So, with these numbers, bang them on your calculator and find out exactly what your grade would be at the semester. If you got an 80 for Q1, 92 for Q2, and a 69 your semester exam, what would be your percentage for the semester? Do that. I'm sorry?
80.
Maybe. That'd be a pretty wild coincidence, but who knows, maybe. .3. Cool. All right. If you say so. I don't have the calculator as you do. 80.3. So is that what you got? So I got a couple 80.3s, but I don't know. Can I get more confirmation than just do 80.3? Okay. So that's a weighted average. A weighted average is where you take a value and you multiply it by a weight, which is a percentage. And we do it when we're doing our GPA or our semester grades. We also do it in chemistry. And what the chemists do is they say, all right, I got 3 isotopes. Isotope 1 has a mass of this and a percentage of this. Isotope 2 has a mass of this and a percentage of this. And isotope 3 has a mass of this, and they multiply them all together, and they get what we call an average atomic mass, which is what's on the periodic table. The average atomic mass is on the periodic table. It has the unit of AMU, or gram per mole. That's the unit we're going to be using, gram per mole. And apparently there's shouting next door, so hopefully the camera's not picking that up. All right, so elements of the periodic table. Again, you don't need to write this stuff down because this is really obvious stuff. You see the element symbol, you see the name, the symbol is the number of protons, the name is in Latin, sometimes it is, sometimes it's not. And then down below, you see the average atomic mass, not the atomic mass. You see the average atomic mass, which is called the molar mass. It is units in grams per mole. And I'm going to explain more about that tomorrow, or Wednesday, because tomorrow we have a lab. I'm going to explain more what a molar mass is on Wednesday. Okay? Now, to get the average atomic mass, we use what's called a natural abundance. A little bit of vocabulary. Natural abundance is just the mass of each isotope multiplied by its abundance, its weight. In other words, it's how much there is. Okay? Kind of like if you wanted to find the average height of all of you, we'd be like, okay, everyone who is 5'8", multiplied by the percentage of people who are 5'8". Everyone who is 5'9", multiplied by the percentage of people who are 5'9". Everyone who is 5'4", multiplied by the percentage of people who are 5'4", and we get an average. That's a weighted average. Yeah. No, okay. Does that make sense? Okay. Because it wouldn't make any sense to just add everybody's heights up and divide by the number, because some of you are different heights. All right, so here's how we do it. We simply look at the molar masses, and we say, all right, you take isotope 1, I'm going to multiply its abundance, which is a percentage, by its mass, which is a whole number. And then I'm going to do the same thing for isotope 2. I'm going to take isotope 2's abundance, and I'm going to multiply it by its mass. And I'm going to do the same thing with isotope 3. I'm going to keep doing it until I run out of isotopes. Then I'm just going to add up all those pieces. And the sum of all those pieces is the average atomic mass, or the molar mass. Okay? If this makes sense to you, give me a thumbs up. You're like, I'm ready to do practice. If you want to talk about it some more, wave your hand around. And if you don't want to take an active role in your education, just sit there. Just sit there. I'm not responsible for anything. I'm not taking I'm not going to take an active role in my education. That way when I fail, it's not my fault. Because that's the way the world works, right? Okay, so, practice? Everybody got a calculator? Everybody got a piece of paper? All right, average atomic mass practice, here we go. There are 3 isotopes of wagnerium, and their abundance is found below. Wagnerium 18 is 25% abundant. Wagnerium 19 is 60% abundant. Wagnerium 20 is 15% abundant. What is the average atomic mass of naturally occurring wagnerium? I'm going to turn on the light so you can see your calculator, if you don't have a calculator that has a light in it. So go ahead and bang on the calculator, and when you see yours, when you see your answer, then show your neighbor and see if your neighbor got the same thing.
You get one little dot.
was done with all this stuff.
I think so.
Yes.
So would you just like multiply 18 by 25?
I would multiply 18 by 0.25. Yeah. If you do 25, that means you have to move the decimal at the end. I think it's better to express percentages as a decimal to begin with. Yeah, I would basically, for this piece, I would go 18.0 multiplied by 0.25.
So you have your answer, what are you saying?
Oh, AMU or gram per mole.
Okay, AMU, that's good. Thank you.
AMU stands for atomic mass unit. Gram per mole is going to be what we're going to be using in this class from Wednesday through May.
Points right
Let's say
there.
that's number 1, right?
And die.
Answer and then.
What is 50?
And I have 4.5, right? Yeah, and then after 30, what did you get?
What is
Are you still
50%
doing
of
it?
1? Yeah.
No, you just add up the 3 pieces and that's it. The dividing has already been done in the weight. So it's not a simple average, it's a weighted average. So the weight does the dividing for you.
So you don't
So
divide
You don't divide it with the
One
end.
is the percent.
And remember guys, any average, the average value should fall inside the highest and lowest value. So it should be larger than the smallest value and smaller than the largest value. It should fall within that range.
This is 1, right? What is 50% of 1? That's
Did you get
50%.
6.3?
Yeah, the 4.5.
So what's 15% of 1?
Yeah.
You get 6.3.
Answer your question.
99% of 1.
That is exactly what you're supposed to do.
What's
That is the answer. You did everything exactly right.
99 or 0.
You know what else need me to take a look at their calculator and tell them they're right? Okay.
Did you get 6.3?
18.9.
Yep, 3 pieces.
Divide by 2.
Uh-oh.
You get the average.
Why would you divide by
Because that's how you get it.
I knew it.
The average is already there in the percentage.
Yeah.
The percentage is the average. That's how much
Oh,
of the heck is.
well then I got it right with 18.
Sounds about right.
I just did extra
Patient
stuff.
0, typhoid Mary.
So wait, what did you guys get?
18.9.
We said that has to be in between the highest point and the lowest point. So you do have to divide by 3.
Yeah.
Yeah, the
The highest point.
I am the father
The
of
highest
I am the
point
father of a 5-year-old who goes to kindergarten,
So then I'm.
a 3-year-old who goes to preschool, and I'm the wife of a preschool teacher. She used to teach calculus with the guy who's actually teaches preschool.
wife of a preschool.
Yeah, I'm the husband of a preschool. You know what I'm talking about. So I get it all. And then you guys come and copy me in like.
No, look.
At the end of the year, my immune system is like just solid steel.
Dude, I literally don't. Okay.
Okay, so hopefully you got a number within the range of 18 to 20.
Yes.
Yeah. If you didn't, something would horribly wrong. So 18 times 0.25 plus 19 times 0.60 plus 20 times 0.15, and you got a value of 18.9 for naturally occurring Wagnerium.
Yes.
Sound good? All right. Let's do another one. The average atomic mass of gallium. There are 4 isotopes: 34 AMU at 9%, 35 AMU at 25%, 36 AMU at 59%, and 37 AMU at 7%. Be careful with the 9 and 7. When you're doing percentages, you still move the decimal 2 places.
Oh.
Okay. So calculate the average atomic mass of naturally occurring gallium.